another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. This episode, to me, definitely is one, I guess, that's kind of close to the heart, you could say. It kind of brings both of my worlds combined. Well, I guess two of the three, if you consider home labbing its own world, but specifically software development and cybersecurity. In this episode, these two titans are basically going to clash and butt heads against one another to answer the age-old question of should developers have admin access to their computers. Now, as a little preface before we get into the episode, as a professional software developer, I have experienced both cases where I have been a developer and have had admin access and been a developer and have not had admin access. So I've had a little bit of a taste of both sides, and also coming from a somewhat of a cybersecurity background, I do understand the arguments for why developers should not have admin access. But again, also as a developer, I also have the insight from the developer perspective of why developers should have admin access. So that's kind of a bit of a debate that we're going to get into in this episode. And I guess I should preface that. I guess I'll preface it later once we actually get to the debate itself. But first, let's get into our trivia question for the week. So this week's trivia question is, where did the logo for Bluetooth come from? So where did the logo for Bluetooth come from? And that is your cybersecurity, not your cybersecurity tip. Oh boy, I am all head on for this week's episode. Completely forgot about the trivia question, but that is your trivia question for the week. Okay, so moving into, I guess, kind of the big-ish news of the week, or I guess one of the bigger stories, is the iPhone is now going to be able to have apps downloaded from third-party app stores. Assuming, of course, you are in the EU once iOS 17.4 launches. So if you're not aware, the EU passed some kind of legislation called the Digital Markets Act, and as part of this, basically it mandated that Apple allow third-party app stores onto the iPhone. And if you're unaware, Android has had third-party app stores for years now, so it's not like this idea of third-party app stores is anything new. If you are on PC, I mean, there's tons of different app stores or game stores, if you will, to like buy video games from, for example. So this idea of multiple platforms to sell or be able to download apps from is definitely nothing new. But for iPhone users, it definitely is. So up until this point, Apple has kind of given the cybersecurity defense, if you will, basically stating that by allowing third-party app stores, it will make the iPhone less secure because their users could potentially be downloading apps that Apple themselves have not verified and vetted to be safe. And for the record, they do kind of have a point there. If they can control everything that you have on your iPhone, including the hardware, software, and even all the apps that you download, they can basically ensure to a decent level of confidence that your iPhone's going to be secure. Now, obviously, nothing is secure when it comes to cybersecurity. As soon as you turn a computer on, it is vulnerable. Like I said, the only truly secure computer is the one that is off in a corner unplugged. Because once you turn a computer on, there's a possibility. But specifically when it comes to the iPhone, there's a lot of ambiguity when it comes to things like what you can get from messaging apps or email attachments or web browser links or things like this. So there are definitely ways that potential security attacks could be posed against the iPhone, but if you really constrict the apps that can be on the device, that definitely kind of limits your attack surface, if you will. So that was basically the argument that Apple was giving, but of course the EU wasn't buying it and have now made them open up to third-party app stores. The other big news kind of coming out of this is alternative browser engines can use their own engines rather than specifically just WebKit. So if you were unaware, basically up until this point, if you downloaded a third-party web browser for your iPhone, for instance, so whether that's Firefox, Google Chrome, DuckDuckGo, Brave, whatever browser you downloaded aside from Safari, it basically was just Safari, just reskinned and maybe have some extra features, because at the end of the day, it was literally just WebKit. But now it seems that this is also going to be opened up, so there will be the ability to have browser engines that don't specifically or are not only limited to using WebKit. So those were kind of some of the big updates, I guess, in the tech sphere, if you will. And normally around this time, we get into our cybersecurity tip, but seeing this, the main portion of the episode is all cybersecurity related, we're going to skip that for this week. But I did want to kind of in the spirit of debate, which we're going to get into, I kind of wanted to bring up a very, very lighthearted, kind of sarcastic argument as to why computer science and software development should be taught in trade schools and not college. Now, as a bit of a warning, because I mentioned this is a very lighthearted argument, so just as a warning, the arguments get more and more out there as we progress further. So the first reason why computer science should be taught in trade schools is because as a software developer, you are inherently a plumber. At least if you deal with languages that require you to manage your own memory, because memory leaks are a thing, and you fix those memory leaks, and what do plumbers do? They fix leaky pipes. So, I mean, basically one-to-one, you're essentially a plumber. Moving on, the next one is an exterminator. I think this one's pretty self-explanatory. I mean, seeing that the majority of your job maybe not the majority of your job, but a large portion of your job as a software developer is squashing bugs. It's one of your core tenets, and exterminators basically kill bugs for a living, so you're basically an exterminator. Moving on to the next trade, you are also a welder. And you are a welder because if those APIs, SDKs, and libraries ain't going to fuse themselves, right? Someone's got to do it. What do welders do? Well, they take two pieces of metal and weld them or fuse them together. Well, as a software developer, you take different parts of code from different applications, different libraries, different frameworks, and fuse them together into a singular program. So in essence, you are also a welder. Moving on to the next trade, we have an electrician. And you're an electrician because by the nature of writing code, you are basically telling electricity what to do. So you're an electrician. Also, if you've ever built a computer before or done any kind of like network cabling or anything, you've ran electrical wire because electric signals, pass through all those cables. So you're basically an electrician. The next one is where it potentially, some of you might think we're getting a little off the rails, if you haven't thought so already. The next one is a carpenter. And you're probably scratching your heads wondering how the heck am I gonna weasel my way out of this one and make it work? Well, I'm glad you asked, because you see here, code has branches. They're these things called if statements. Switch statements also kind of are branches as well. But if you needed any more proof of this, if you think I'm just pulling your leg here, I'm not, because in assembly, there are actually instructions called branch instructions. Branch not equal to, branch equal to, basically ways for the CPU to say if these two things meet a certain case, like they're equal to for each other, jump to a different location in memory and perform other instructions, which is in essence an if statement. So code and programming has branches. Also, if you happen to be using Git for your source control, Git also has branches. So you're really working with a ton of branches here in your software development. And where do branches grow? That's right, they grow on trees. And where does wood come from? Wood comes from trees. Therefore, branches are wood, and carpenters use wood to make things. So because programmers use branches in their programming to make things, in essence, they are using branches, which is wood, to make things. Thus, they are using wood to make things, thus making them carpenters. Thank you very much. Moving on to the last one, we have masons. So masons, specifically the ones that work with like rocks and stones. This one you're probably saying there's no way he's going to be able to pull this one out of his behind, but you would be wrong because I'm about to. So you see here, silicon comes from the Latin word meaning flint or hard stone. And I bet you can't guess what CPUs and GPUs are made of. Silicon, aka stones. Therefore, when you're writing code, you are basically building stuff with stones, aka the silicon in your CPU and GPU, thus making you a mason. Thank you very much. I'll be here all week. And I think that basically sums it up that computer scientists and software developers are essentially every single trade in the book. Of course, I missed some, but you're basically all of them, so you might as well lump it in with trade school. So thank you for coming to my TED Talk today. And with that bit of wildness, let's get into some more wildness with what nerdy stuff have I been up to this week. So I have kind of had a quest the past, I don't know how long, to try to reduce the energy consumption, the juice, the wattage that my home lab sucks down on the regular. And I am happy to announce that I managed to reduce the power consumption of my R620 by 10%. And you might recall that the R620 is basically the backbone of my home lab. Like if you remove the R620 from the home lab, basically everything's gone. Not everything. I still have some other services running on another hypervisor, and of course my NAS is its own thing. But a lot of my services and things that I use run on the R620. Now, if you're wondering how I managed to reduce the power consumption, at least the idle power consumption, by 10%, I basically just removed hard drives I wasn't using, and that was it. It was literally that simple. So if you didn't know, hard drives consume a decent chunk of power. So on average, I think the estimate is anywhere between like 5 to 7 watts for a hard drive, roughly. And I had 3 hard drives sitting in there doing nothing. I had this grand vision to So when I first got the R620, I had 3 hard drives in it that I basically used for virtual machine storage or VM storage. And as the number of VMs grew, I noticed whenever I would try to do things like run updates or bring up and down multiple VMs at the same time, the I/O delay would absolutely skyrocket, basically making the system unusable for a decent amount of time because hard drives aren't fast. They're called spinning rust for a reason. Now, recently, I guess probably within the past year, I found what I thought was a pretty good deal on some old enterprise SSDs. So I basically bought a lot of them and upgraded my R620 and one of my other hypervisors to flash storage for the VMs rather than the spinning disks. And that has improved the performance tremendously. But since then, I had kept the hard drives installed in the systems, partly because I had this vision that I was going to use them to do more frequent, like, VM backups, just to have them, like, locally rather than copying them over to the NAS, for instance. But that never ended up happening, and I figured I probably don't really need that, so they were just sitting in there. And then I remembered again of how much power hard drives can use, and then I also remembered the fact that these hard drives are literally just sitting there, so they're basically just sitting there sucking down juice for no good reason. So I decided to pull them out, and then of course the R620 got mad at me because I had ejected the drives while it was still running. That's one of the nice things about hot swappable drive bays is you can just do that. So then after going through the iDRAC interface and clearing the logs so it would stop screaming at me, I then decided to continue to monitor the power draw. And I noticed that the power consumption dropped by probably a good 15 watts, which makes sense seeing that I pulled 3 hard drives from the system. So I basically dropped 15 watts and lost nothing. It's not, I didn't, sacrifice any performance. I didn't sacrifice any RAM capacity, any processing capacity. I didn't sacrifice anything, and I saved 15 watts. So, and I mean, it's not much, but, seeing that the R620 is literally running 24/7, 15 watts times 24 hours times, 30 days in a month or whatever, it definitely will slowly add up over time, and like I said, it's not much, but it's something, I guess. It'll probably be one of the justifications for me turning another piece of hardware on or having something else run more often. If we're being completely honest, that's probably what it's going to do. But anyway, the other nerdy thing that I wanted to touch on was me being fancy and it biting me in the butt. So one thing that I'm pretty sure I've mentioned on the podcast before is the idea that you shouldn't be fancy when writing code, and you should write code that's really easy to understand because it helps you understand it when you come back to it, and it can help other people trying to read your code understand what's going on. But I guess in this instance, I wasn't necessarily doing anything like, I don't know, writing like a Lambda function that has like 10 different mappings and two other nested lambdas and basically making this one line of disgustingness that I've had to write before, which was absolutely horrendous. But it wasn't anything like that where it was super unreadable fancy. It was basically me saying, I don't want to create another variable, so I'm just going to pass a pointer around. And because I did that, I ended up getting nipped in the butt, but it's also kind of partly self-inflicted. So let's kind of walk through what happened, go through my thought process, and maybe you can kind of see where I started to go wrong. So over the past couple weeks, I have been trying to integrate the front-end GUI of the battle portion of the video game I'm making with the back-end portion. So I had written the back-end portion a good while ago, at least most of it. It's not completely done, but a decent amount of it. And recently I've been trying to integrate the front-end aspect of it, so it's not just like a terminal-based thing. So as part of this, I had created a struct to essentially pass back all of the data that I wanted or needed to capture from the back end to the front end so that I could use that to process it and display the appropriate messages and all that good stuff. So part of that was one of the variable in question that I was trying to pass into one of my functions to set it was a uint16, or a unsigned short. And I was passing this as a pointer, mind you, and casting it as an integer because the function itself took an integer pointer. So the eagle-eyed among you probably can already see the issue here. But the issue I actually ran into was during this process of integrating the back end and the front end, things seemed to be working, but then depending on if a status condition was set that would cost the user or the person with the status condition to take damage from it, if they also were susceptible to confusion damage, they wouldn't take any confusion damage, and it would basically print out the default unable to move message, which I knew was wrong. And I could not for the life of me figure out why this was happening, because it was intermittent. It didn't always happen. It only happened sometimes, well, basically all the time, but because of the pseudo randomness in each turn, it seemed like it wasn't really happening all that often, even though it kind of was happening every single time. But basically, if a certain status condition was set that would inflict damage, and they would also inflict confusion damage, the confusion damage would be set to 0, and that was basically what I was using to check if they needed to be, basically to print out if they had been hurt in confusion. So I was kind of lost at this, and I kind of gave up at one point and was like, I'll just come back to this later because it's kind of an intermittent thing. And then I got back to it and realized that this is basically what was happening. So like I mentioned, the confusion damage and the status condition damage were both uint16s, which are unsigned shorts, which take up 2 bytes. And what I was doing was I was casting this uint16 as an integer and passing it into the function. And and here is where the eureka moment kind of went off, and I realized how dumb I was, because I have this structure, right? And inside this structure is a collection of bytes. And An integer is 4 bytes. A unsigned int, or rather an unsigned short, or a uint16 is 2 bytes. So in essence, what was going on was when I was passing the address of this uint16 or 2-byte object, if you will, and casting it as an integer pointer, which is a 4-byte object. Now, granted, pointers themselves are 8 bytes, but because we're casting it as an int, it's basically telling the function or the compiler or whatever that this thing coming in is 4 bytes, so write 4 bytes worth of data. And that's basically what was causing the issue. So because initially I couldn't see, because first off, I thought it was a copy-paste issue. I thought somewhere I was setting the confusion damage in the wrong spot and accidentally overwriting it and setting it to 0. But that wasn't the case. The issue was the damage by the status condition, what just so happened to be right above the damage for the confusion damage. So when you actually take the bytes themselves from the structure, passing the address to the status damage, and you cast it as an integer, rather than it just being the 2 bytes for the status damage, it's now 4 bytes, which also encompasses the confusion damage. So basically what was happening was I was passing in the status damage and writing 4 bytes to it, but because it can only hold 2 of them, those extra 2 bytes were being spilled over into the next variable in the struct, which just so happened to be the confusion damage, overwriting it, setting it to 0, and thus being the crux of my problem. So basically what happened was I was causing an overflow of sorts and corrupting my own data because I was trying to be fancy. So I know that was like super deep into the weeds, so hopefully I didn't lose people. But in essence, basically what happened was I had a structure, and in trying to be fancy, I basically told my function, here are 4 bytes worth of data, fill them up with the data that needs to go there, and be done with it. But the problem is those 4 bytes I was giving it was actually 2 separate variables. So in the process of saving the data to those 4 bytes, I was overwriting one of the variables I had previously set. So hopefully that makes sense. I know we got super deep into the weeds on that, but I had to kind of try to explain why me being fancy and passing the reference to the struct, the variable in the struct, came back to bite me. So then, of course, the solution was just create a temporary integer variable and pass that into the function, and then set the uint16s afterwards. So that fixed the issue, and now, as far as I can tell, I'm pretty sure at this point the back end and the front end, at least to the extent that the back end has been completed, which, like I said, is not done, is now like fully integrated into each other, aside from like animating things. So the health bars, for instance, don't animate like as you take damage. It basically, after the turn's over, all the damage that's going to be dealt during that turn has already been deducted, and there's no animation at all. So that's still something that has to be done, but that's kind of a minor thing. As far as like actually integration between the front and the back, it's basically done at this point, at least to the extent, like I mentioned, that I had the back done. So now let's get into the main topic of the episode, which is, should software developers have admin rights on their computer? Now, as a biased developer, I say absolutely yes, developers should have admin access. So here, I guess, is where I have to disclose a little bit of my bias here. I am a software developer, and personally, I would actually love to have admin access to my computer because, in my opinion, it makes my job as a software developer not only easier, but more efficient. But on the other hand, I've also have a cybersecurity background, so I can see why that's not a good idea to allow the software developers to have admin access to their computers. Because in all seriousness, as much as I would love to have admin access to my computer, the principle of least privilege says that I should not, because I am not a sysadmin. I don't need to administer the computer. I write code. Therefore, I do not need the privilege to have admin access to my computer. Now, as we'll kind of get into here, we will kind of give both sides of the argument. So you could make the argument that developers do have the need to have admin access. But also you could also make the argument that they don't. But if you wanted the most robust security, say for your organization, then no, your developers should not have admin access. But that does come with some caveats. But like as we mentioned, with everything with cybersecurity, cybersecurity comes at the cost of convenience. If something is convenient, it's basically almost never as secure as something that's inconvenient. Although I should note that that's not a, always a sure thing. But in general, that tends to hold true. So this is kind of the debate that I had within myself as a full-time software developer and someone with a cybersecurity background. It's something I've kind of gone to war with, I guess you could say, in my mind. So let's start off with the reasons for why developers should have admin access and some pros and cons to each of them. So I think the most obvious one is the flexibility that it gives the developer, and in general just allows them to be a heck of a lot more productive. So like I mentioned at the beginning of the episode, as a professional software developer, I have had the experience of both being able to have admin rights on my computer and not have admin rights on my computer. And I have to say, having the ability to be working on some code and realizing, oh, I need to go download this, I need to go download Wireshark, or I need to download a virtualization software to do some testing on another operating system, or I need to install another library or another tool in order to better test or develop my software. It was so easy to just be able to go do that and be able to get right back into the work I was doing immediately and not having to rely on putting in a support ticket and waiting for IT to log into my machine. And it just added so much more flexibility to my work schedule and also allowed me to be a lot more productive because I could actually, once I realized I needed something, I could just go and download it, install it, and be off to the races and continue my work. I wouldn't potentially have days, weeks, months of downtime waiting for IT to finally get their act together and install whatever they needed to on my system. And sometimes I've also had the issue where IT would install something on the system, but they wouldn't either configure it properly or install it properly, and things didn't work. And that's one of the nice things about being the developer, because sometimes IT guys are great at administering devices, but they're not like experts at like certain niche pieces of software that developers might. So if they're just going through an automated install, they might not check all the boxes that you need to be checked, and that could also potentially cause some issues. Another benefit is it can, in addition to being more productive, it can also speed up your development time too, because if you have the freedom and the ability to quickly test and experiment with different libraries and frameworks and APIs and that kind of a thing by, installing them on your computer, it makes it a lot quicker to experiment with various different things, kind of get a feel for which library is going to work the best or which SDK is going to work best or all that kind of stuff. And you're not necessarily beholden to one singular thing, which may or may not, actually be the best tool for the job, because you don't have the flexibility and the ability to easily install something new. And another big one, which might actually be not as obvious, is debugging and troubleshooting. So one thing that having admin access is pretty nice for is it allows you certain debugging and troubleshooting capabilities that you wouldn't necessarily have if you didn't have those rights. So specifically because if you have admin rights, you basically get higher level privilege to access system level issues. So if you're running into a network issue, for instance, you have the ability to go in there and change your network configuration settings to basically troubleshoot and diagnose if maybe you're not connected to the right network, or maybe your IP address is on the wrong subnet, or maybe your DNS isn't configured properly, or whatever the case is. You have the ability to go in there and test and troubleshoot those issues. Whereas if you don't have admin access, you don't have that ability, so you're basically left beating your head against the wall and trying to speculate as to what the issue might be, and it really inhibits your ability to debug and troubleshoot your software. Another one is environment setup. So every developer has their environment set up. So some developers like a certain IDE, some like just to use a standard text editor, some like certain development tools over others, and having the ability to install your own software basically gives you that freedom to customize and make whatever preferences you want to your development environment to make it better suit your needs, rather than some, one-size-fits-all solution that might not work best for you and your workflow. So having the ability to experiment with, test, and change up your workflow and overall testing environment, whether that's you're changing your IDE, installing a new one, installing a different tool chain for your builds, whatever the case may be, you have that ability, you have that flexibility to find what works best for you and to make your overall workflow better. And the other one, which I guess is kind of obvious, is you kind of reduce the dependency on the IT team, which, with how much IT gets blamed for everything, you would kind of think that they would want less of the strain and burden on them. So if you give the developers, which, let's be honest, are sometimes the most demanding when it comes to IT tasks and, software installs and that kind of a thing, you basically reduce your workload. So having developers, system level access to be able to manage their own systems and install things, they don't have to wait for IT to, push an update or wait for IT to manage their system, because I cannot tell you how many times I have been trying to do work and be productive only to then be kicked off my system for the sysadmin to come on and either perform updates, do installs, whatever the case is, and really hits my productivity and just it's not fun. So having the developers be able to manage their own devices, they can, kick off these system updates at their leisure when it's more convenient for them, reducing downtime, allowing them to focus on their work when they're most productive, and maybe, kick off that update when they go off to some meeting or something, rather than when they're in the middle of the groove, in the middle of working on a feature, and they're not getting kicked off for an admin to come on to do updates. So reducing the reliance on IT is another potential positive, and I think it's kind of not only a benefit for the developer, but also for IT departments in general. But now we get into some of the disadvantages of having a developer with admin access. And the number one is probably security risks. And I guess it kind of comes down to with great power comes great responsibility. Because admin access basically allows you to install whatever you want. And one thing we've talked about on the podcast before is that you want essentially the least amount of things installed on your computer that you need in order to reduce your attack surface. But if developers have access to the system and are able to install whatever they want, they could be potentially installing either potentially malicious things or other pieces of software that could potentially open them up to other vulnerabilities that other devices on your corporate network wouldn't have and you wouldn't necessarily be accounting for. The other issue with having developers essentially managing their own IT infrastructure is you don't necessarily know what's on their system. So that is one nice thing about, everything being run by like the sysadmins and the corporate IT personnel is they can basically get a rundown of everything installed on every single device. And while that might kind of seem a little big brother to you, from the cybersecurity perspective, it makes it a lot easier to diagnose what systems are vulnerable, what patches need to be pushed out, and overall how to make all the devices more secure. So if you see, in the news that X piece of software has this 0-day vulnerability, if there are certain devices that you need to segment from the network in order to isolate to make sure that any potential attack or infection of that machine doesn't infect the rest of your network. But if you have developers off running willy-nilly, installing whatever they please, you lose that ability to know of everything that's installed on the system, and some developer could have had installed some piece of software that you didn't know about that has a 0-day. Their device gets compromised, and now your network is infected. So that is another potential issue with allowing developers full free reign, essentially, to install whatever they want. Another issue, potential misconfigurations. I mentioned sometimes IT personnel will sometimes misconfigure, misinstall something, but developers can do it too. And for instance, if you have a specific, say, network configuration that works for your corporate infrastructure and a developer's messing around with settings trying to configure things to work and they mess those up, that could potentially cause issues. So those are kind of like the main disadvantages for having developers have admin access. In essence, you basically lose control of knowing what's installed on all your devices in your network and being able to easily account for any kind of potential vulnerability, because like I said, if you know every piece of software that's installed on all the machines, you can essentially keep an eye out for issues with those pieces of software in order to make sure all the patches go out on time, and to see if there's any potential issues or exploits that you need to be aware of. But if you don't have that, then you're kind of, at the whims of hoping that developers update the things that you don't know that they have installed. So now we get into some of the benefits of developers not having admin access. And it's basically the things we kind of talked about, but in reverse. So like I kind of mentioned, if developers don't have admin access, you can have enhanced security because, one, you're implementing the principle of least privilege, which, of course, is, the idea of limiting the amount of people that have admin access, limiting the attack surface. The other thing of it, too, is if developers don't have admin access and someone somehow compromises their machine, or their account, for instance, that person or that attacker does not also thereby have admin rights. Because one thing that you have to keep in mind, and this is where reducing the attack surface partly comes in, is if your account gets compromised by a threat actor, that threat actor has whatever privileges your account has. So if you have an admin account, they now have admin access to be able to do whatever they want. But if you were just a generic standard user, what they can do as an attacker, the damage that they can do is a lot more limited because they don't have the admin rights in order to do certain things. So that is one thing that not allowing developers admin access definitely improves. And in addition to that, like we mentioned, you don't have the developers willy-nilly installing whatever their heart pleases. So that also limits your attack surface by ensuring you know what's installed on all the various devices. And that basically allows you to have a standardized environment, which makes the lives of IT administrators a lot easier, because there's a standard development for deployments. There's standardized methodologies for updates. You can essentially, it makes it a lot easier to automate those things, because if you know what a standard imaging for a new device is, it makes that a lot easier. If you know everything that's installed on a machine, you can essentially automate the updates for performing those updates. So basically just allowing you to control the changes to any system configurations if all the systems are configured the exact same, or you have the developer machines that are configured one way, and then you have your sales departments configured another way. If you have those standard configurations, it also helps reduce the likelihood of you accidentally misconfiguring something and making someone's computer have a not good time. But if developers have admin access, though, and they change some configuration settings during either a debugging process or what have you, that could potentially cause you to misconfigure something and change something and cause an issue to the device. And also the last point here is it makes it a lot easier to provide support and maintenance, because if every device is the same, it reduces the number of variables at play. So if you have, 5 different devices with 5 different configurations and 5 different loadouts of software, every device is its own beast. Whereas if all the devices are configured the exact same, running the exact software, the number of possibilities is greatly reduced, and the chance of, if someone has an issue, you've having already solved that being a possibility, or if it's something you haven't solved before, the chance that someone else might run into the same issue and you can pull back from that history of something you already solved, that is also kind of a benefit. And when we come to the disadvantages, though, of developers not having admin access, we kind of get back to basically the inverse of the benefits of the developers having access. So basically reduced productivity, like I mentioned from personal experience, having to wait for IT to install something or reconfigure something, add a new tool, add a new library. It can really slow down the production process and really, like we talked last week about, productivity monitoring things like, the task boards, for instance, to monitor progress of developers. Well, if you're a corporate entity and you only care about software being churned out as quick as possible, if your developers don't have the admin access to install all these various tools and dependencies that they need, it's going to reduce their productivity, make them not be able to write as much code, hinder their ability to do proper testing, and that's just going to lead to less productive developers, potentially worse written code. I mean, there's definitely a lot of downsides that developers can run into by not being able to install what they need to when they need to. And then we kind of get into that other aspect of dependency on IT, and that's just another department in your corporate infrastructure that's reliant on your IT department. So, I mean, IT departments are notorious for kind of being overworked with all the tickets coming in. And then, of course, they get blamed for absolutely everything because everything's IT's fault. Even if you forgot to connect your laptop to the corporate Wi-Fi, it's the IT's fault for your computer not connecting to the internet. You know the standard stuff. So having another section of your corporate employees being solely reliant on IT just adds more work to the IT department. Not to mention the fact that in some cases, I mean, the developers, not always, of course, but in some cases, the developers are just as competent as IT personnel, especially if they have, potentially cybersecurity backgrounds, or maybe they're home labbers. They have some experience with this, so they don't necessarily need to be dependent on IT, but, having another section of your corporate infrastructure being dependent on them just adds more work to IT. And that could potentially add more bottlenecks because, like I mentioned earlier, developers can be rather needy at times when it comes to needing things installed or reconfigured or what have you, because over the course of our development process, we realize we need something installed. So then we submit more and more tickets, which gives IT more and more work. But if we had admin access, all those issues would kind of go away, if you will. So, and in addition to that, another thing is if developers don't have admin access, one thing developers like or is beneficial to them is have lots of devices, whether that's servers, laptops, environments, virtual machines, whatever the case may be. We like lots of environments. And if we don't have admin access to all those environments, guess who now has to manage them all? That's right, the IT department. So if we want extra VMs to do testing for our builds or testing our software, say we're developing on Windows and we want to test the Mac OS and Linux versions of the build, we need other devices for that. But if we don't have admin access, then we need the IT department to manage those devices for us. So adding additional devices to IT's loadout, increased workload for IT, and then just overall frustration on both sides, to be honest. IT's side, because they're kind of annoyed that the developers keep hounding them to install things or configure things or what have you. And then you have the developers getting frustrated because they're like, if I could just have the admin access, I could do this all myself and be over with this a heck of a lot quicker. And I could set up my environment the way I want to, and I could install the things I need, and I wouldn't have to go through IT and be more productive. So there was definitely frustration on both sides that comes for not having your developers have admin access. So at the end of the day, should developers have admin access to their machines? And I think we have to give the answer to the trusty, reliable, it depends. But I think if I had to give a definitive answer, I would probably is because I'm biased, I would say give the developers admin access with some caveats. If you really want to be secure about things, you can go about it in a couple different ways. One, you could give them like a separate device for their development, so that if they do mess something up, you mitigate your risk. So you could imagine you essentially have a network specifically for the developers' machines. So whether that's their development workstations or their development environments, you have those kind of on their own separate infrastructure. And then on the other network, you have the rest of your corporate infrastructure. So in the event that a developer maybe installs something they shouldn't, and you limit what that attack surface is. You basically protect your corporate infrastructure from the development infrastructure. That's one way you could go about it. Another way you could go about it is ensuring that your developers are all properly trained, which everyone, I'm pretty sure, hates training when it comes to work. It's one of those necessary evils where you just kind of know wherever you go, you're going to have some kind of mandatory training. I know developers don't like it. I don't think anyone does. But if you want to give developers admin access, that could be one of the things that you tell them. Be like, okay, you can have admin access, but you need to complete this training. That could be another way to go about doing it. Or you could just let them have it. Be like, we trust you. Do what you want to do. The other thing I guess you could potentially do is you could set some limitations to their access. So I know I gave a story. I don't remember when it was. It was a while ago. But I gave a story of one of the work laptops I had where they basically disabled writing to USB drives. So that could potentially be something that you do is in the firmware or the BIOS or on the hardware level, you restrict access to certain things to try to limit some of the things that developers can do. But even in that case, I did, if you remember the story, I did find a way around that restriction of not being able to write USB drives. The solution was create a VM. So yeah, that was a fun story. But yeah, so there's definitely different ways that you can go about managing that. But if you are super duper paranoid about your cybersecurity footprint, then I would say absolutely do not let developers have admin access, because developers, if they have admin access, will install things, which you may or may not want them to have installed. And you having the essentially authority, if you will, to vet everything that they install can basically ensure that, not ensure, but mitigate the risk that you're adding to your attack surface, if you will. But as a developer, I definitely want admin access. I think it makes my life a lot easier, and I like to think I'm a fairly competent person when it comes to administering systems. I mean, I kind of do it for fun in my home lab. But I do, as a cybersecurity conscious individual, understand the other side of it and why, in all reality, I probably shouldn't have admin access. But from the raw productivity standpoint, there's definitely a serious benefit of giving developers admin access. But again, it comes down to what's your risk tolerance. How willing are you, do you have strict deadlines that developers have to meet that any potential delays could have serious impacts on you? I mean, there's a ton of different things that you have to weigh when it comes to should your developers have admin access. But I think in general, there are definitely ways that developers can have admin access and definitely mitigate the overall risk for your overall IT infrastructure. So my personal opinion is developers should have admin access, but again, that is very biased because I am a developer and I have experienced firsthand what productivity looks like and how much it can be hindered by not having admin access. But again, like I said, at the same time, I totally, fully understand the argument from the other side of why they shouldn't have admin access, and it is definitely 100% totally valid. So that was kind of the rundown, the debate. I'd be interested to hear what you guys think about this. Which camp are you on? Are you a developer and want admin access? Are you a cybersecurity IT professional and you never want developers having admin access? You can let me know at contact@darkassassins.inc.com. Also, if you have any questions, topics, or comments for future episodes, you can also shoot me an email there as well. But before we go for today, we should get back to our trivia question for the week, which is, where did the logo for Bluetooth come from? So where did the logo for Bluetooth come from? If you said the Nordic runes for H and B, you are correct. So specifically the Nordic runes for H and B, because combined, Bluetooth is actually named after a king of Denmark called Harald Bluetooth from the mid-900s, so a good while ago. But the H and B come from his name, and when you combine the Nordic runes for the H and the B, they make the Bluetooth logo. So that is where the logo came from. And if you enjoyed this episode, or if you want to let me know which side of the debate you fall on, shoot me an email at contact@darkassassins.inc.com. Definitely share this episode around. And yeah, that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.